I thought we did this, oh, no, wait. Did we do that one together? I thought this was the second problem we did together. Yeah, okay. So we're on example 4. Okay, now, I don't like myself for doing this, but we're going to do this. We don't have time to sit there and write every single problem the long way. Just, to be honest. So, the long method that we wrote, I showed you one way to do it. I know the answer key to the packet has another way that's pretty similar. She likes to write it in like steps, like numbered steps. So, you definitely have a lot of examples to look at of the official way to write L'Hopital. Oh, and I got verification. I forgot I have a French exchange student in my 6th hour. It is L'Hopital. The little caret thing apparently is a, they call it a hat. And if you write that little caret above the O, then you don't write the S. So if you don't write the little symbol, then you write the S. Apparently. Which is also weird because le, I believe, means the. So his name is The Hospital. So in terms of remembering how to spell it, I already guarantee everybody's going to spell it La Hospital, right? So I haven't decided on our test if I should have you write it. I feel like what I will do on our test is there'll be a handful of L'Hopital questions. I think one of them I will make where you should write it the official way. And so I can grade you on actually how you present it. Because I think that's going to be important for you to remember for the AP test. But in terms of time, it just sucks up way too much time to do that for every problem. So if you'll notice, these notes are actually pretty long, and there's a lot of different kind of examples. So I kind of feel like we're not going to do that today. I don't like it, but I don't know. I also don't want you to be cut off of examples to work on together to know how to do them. So let's start with this one. Two. What do we do to start the problem? Table 2. Yep. Plug in the number, which I'll save you some time and tell you it's going to be 0 over 0. Go. What do we do after that?
Do we have to do like the since limit?
We're not going to write that today, but yes. That part is absolutely correct.
Then we have to find the derivative of the talking about.
Good, good, good. I'm waiting for you to write it though. You guys look very reluctant. There's safety in numbers. And these are easy derivatives. Although maybe I don't want to jinx you doing that. You got this. The class is counting on you. So 100% just write this shorthand. We don't need to write this officially in any which way. Because the problems go very quick when you're just doing them to find the answer rather than trying to prove it. Why do you guys look so hesitant?
Do I have to write like the limit, like the beginning part?
Let's just shorthand. Today we are doing unofficial everything. We're just trying to find answers. Okay, what do you do after that? Plug in -2 again. Well, I don't know. I can't remember if this one goes multiple times or not. Top, we have -12. No, we'd have 12. 12 minus 4, 8 minus 8 would be 0. 12 minus 32 would be negative. Wait, am I adding that right? 12 minus 32? -20 plus 20, so it is 0 over 0. So then we got 0 over 0 again, and then what would we do next?
So now we have to find the derivative of
Yes.
these again.
Now, the good thing about this problem is the original problem was cubed, so we know it can't go that far.
Yeah.
It's only gonna go a couple steps. Okay. Yeah, I would say right here is where it's gonna stop, because,
Yeah, maybe it's
negative 10, 4? I think 4.
Yeah.
Okay, and then on the test, you would write the answer.
-5/.
There we go. I don't know why, but on that last test, a lot of people were forgetting to simplify. I think they were just stressed from the pressure of the test or something. I don't know. Perfect. Nice job. Yes.
What would be correct notation? What would be correct notation? Like, y prime,
Oh, you mean like, you talking about an official thing?
yeah, like if this were on the test and you got this.
So there actually isn't much notation to begin with. The only difference is instead of what they wrote, before each fraction, you should write limit as x approaches -2.
Okay.
But do you have to like simplify your taking the derivative?
So you don't have to say that you're taking derivative.
Oh, God. I 100% get what you're asking. You just don't want to lose points on a test, is what you're saying. Yeah, I get it. So this is what I was trying to say at the beginning of the hour, that I feel like what I will do is I'll probably have like 3-4 L'Hopital's questions where I just want you to find the answer.
Okay.
And then I will have one where I will grade all of the work and everything. That's what you're trying to ask mainly?
Yes.
Yep, sure. No, I get that part. I don't have a great answer, because if I'm allowing you to not do the correct way, I feel like it would be kind of hypocritical to take points off for not writing limits repeatedly as well. So I feel like I should do an all or nothing in terms of fairness. All right, does that feel okay to you guys? Okay, the downside to all or nothing is, I wouldn't grade your work. So it's right or wrong. I wouldn't make them worth a lot of points either. I mean, like, I would expect them to go fast, I guess is it. Okay, next page. Do you guys have a table you want to choose, or should I roll? One. Yeah. Now I realize it's been a while since you used limit properties, so I can refresh you some of those if you need it.
That'd be wonderful. You have to do check your right for the time check. Or it's product.
No, it's chain.
Chain
No,
is
you're
product.
right, you're right.
So where do you want to start?
Decided to start with the top.
Are you doing product rule on the top?
We were about to.
Is that correct?
It's not wrong, you just don't want to.
You don't want to.
Don't worry.
Product rule would work, but would make it a lot of work.
Okay.
So one of the properties of limits is that you can separate a limit into two individual limits being multiplied.
So like limit of sine x over.
squared times.
Sine x over x, 1 minus cosine x over x.
Oh, okay.
Those are the
So
two
it's
special
right.
trig limits. So yeah, I don't know if you guys heard that part. They were gonna do product rule on the top, which is correct. It's not wrong,
Time.
but it would just get very ugly and very long. One of the limit properties that we learned forever ago is that you can split apart a multiplication into two separate limits. Can't see? Yeah, I understand.
It looks like
It's okay.
Okay. Anyway, so
Take the derivative. Take the derivative.
okay. So you can do this. Cosine.
No, that's 1 minus cosine squared.
What is that, that's just,
One
that's
minus
nothing.
cosine squared.
Derivative of 1 minus cosine should be,
It's 0 minus
Yep.
sine.
Plus.
Or plus sine.
yep,
So it should be sine.
yep.
One
Okay, now plug in 0 to see if you can get an answer.
plus cosine of 0.
Cosine 0 is
Good,
sine 0 is 0.
good.
Seth, you're doing the last part.
Well, you basically just said the answer already, but okay.
So what,
Never
0
mind.
over 1, right? You
It's
said
1 times 0.
1 times 0, 0.
Does that count as a, well, 0 over 1, yeah.
Well, 0 over 1, but that turns out
Yeah.
to be 0.
Okay.
You don't even need to write over 1.
So are we done?
Yeah.
Yep, that's it.
Cool.
Now, this problem would have been far worse if you did product rule, which isn't wrong. It just would have been a lot of steps. You would have gotten the exact same answer. But my guess is you actually would have had to do it twice because the denominator would have been 2x on the first derivative, on the second derivative. Although, I don't know, I haven't tried it. I don't plan on trying it. Does anybody know a different way we could have done this problem rather than L'Hopital? What? I was hoping somebody would be super clever about this one. Andrew, you can't be asleep. Calc is not boring. You're just tired. Oh my goodness, I felt that dagger right in my heart. Oh, go ahead.
Sin x by x times of 1 minus cos x by x.
So their first step that they did, you guys broke it up to try to do L'Hopitals, which is fine and correct. But these were the two special trig limits that we learned forever ago. And the answer to the first one is 1. The answer to the second one is 0. So because they are known limit answers, you don't even have to do them. You can just immediately write the answer.
Sin x over x is equal to
Yeah, if you remember that fact, no, you need that. If you remember that fact, you are able to just write the answer.
Is it 1 minus cosine x or cosine x squared?
1 minus cosine
Just,
x. You're probably somewhat confusing it with Pythagorean identities. 1 minus cosine squared x is sine squared x. Either way, if you didn't remember those facts, L'Hopital's 100% works on it to find the answer in one step.
Why does L'Hopital's work?
Ooh, let's,
Someone decided
so if you want to look up the proof for L'Hopital's, it's relatively large and it works. That's definitely the type of proof that let's see, I'm trying to remember what movie that was. It wasn't Good Will Hunting. There's not many movies with mathematicians, right? But a common known thing among mathematicians, but probably not normal people, is if you prove something that people think to be true. Like, people knew these answers before it was proved. If you are able to prove something, you can actually get paid a lot of money. I want to say Fermat's last theorem. We haven't had it yet, but I believe I saw that in a movie once. Like, he spent 10 years in his attic proving this theorem. And you get like, I don't know, it's like 150,000. It's not like life-changing money. Although, who knows, maybe now it is, I don't know. That was a while ago. But these types of proofs take a long time even just to write. More or less be able to follow and figure out. It definitely is smarter people than me that don't forget things after 30 seconds. Because I do. 1 million? Oh. Yeah, it's like a worldwide mathematician group that like verifies and checks these things out to see if you proved it, and they've just got a big bank account of money apparently. I guess a million's not bad. Unfortunately, it's not life-changing anymore either, which is kind of sad.
Does L'Hopital work for any limit?
Any limit that is an indeterminate.
Oh, yeah, I forgot about that.
Yeah, no, it actually would be pretty cool if it worked for every limit, right? It's the indeterminate limits were the ones that people had a hard time finding an answer to previously. So that's why it's helpful for those. Okay. 5. Hi. Wait, who's missing? Oh, Owen just left. Yeah. You guys basically just stared at it for a while. These are intended to be quick. That's why I'm having you guys come up. And we get done at 10:06, so don't waste too much time.
Okay. Either one that's,
It'll be 0 over 0.
okay. So we gotta do what we call, so that we take derivative of natural law.
That's why I wanted you guys to come up to remember derivatives. Dan, he's looking for some help.
Yeah. Oh, wait,
Yeah, you do.
wait, the derivative of top and bottom?
Yep.
Yeah, so what's derivative?
Oh, I don't know, Ellen. Is that
That's-
one over X?
Yeah.
One over X, okay.
So 1 over x minus 1 over e dx.
Good.
Oh,
Good.
and then don't we do chain rule for e dx or no?
Sure. Times 1.
Yeah. No? Oh, wait.
Derivative of e is 0. Yep, it's just a regular number.
Okay, and then,
There you go. That's the correct derivative.
so then this simplifies to 1 over 1, so 1 minus 1, which is 0, and then e to the 1 is e, right? So times 1, so it'll be 0 over 1.
There, 0.
E times 1 is e.
Right, yeah.
So the answer is
0.
good. No. You don't write 0 over e.
Oh.
No, that's not wrong.
Oh, e to the negative 1/2. E to the negative.
Well, you're thinking way too hard on this one. Dan just said the answer. And 0, whoa, I don't know what that is.
Don't know what I did either.
That was weird. Okay, now here's something that you may, this question is here for a reason.
Where'd it go?
I would, what, say what?
The screen like cut down.
Oh. I mean, I knew I saw the blue lines, but I didn't realize. All right. You guys broke the computer. I like this question here because I bet some of you would have gotten an answer of 0 on the top and immediately been like, oh, L'Hopital's again, and then done the derivative one more time. And you shouldn't. You have to figure out the answer for the top and bottom because 0 over a number is an answer. And even if you get a number over 0, that's an answer as well. It's undefined. You have to have an indeterminate to use L'Hopital's. Okay, good. Let's hopefully the next page shows up. All right, good. Oh, here we go. I think the bottom of that last page said it was infinities, right?
Yeah.
Yeah. Okay. Well, we'll just skip to this one since it's cut off. They're all virtually the same, so it's not a big deal. So on the infinities, it works the exact same. You're trying to find out if it's an indeterminate first. Now the rules of infinity, they're kind of shady. When I plug infinity in the top, 4x squared is what I focus on. It is infinity, yes. On the bottom, e to the 2x is much bigger than ln of x, because ln of infinity is a much smaller answer than e to the infinity. So this is considered a higher degree. Okay, so our answer would have been infinity over infinity, which means L'Hopital's applies. Now, we're going to pretend that we did not learn how to judge the degrees up top and bottom, because we're kind of mixing real math and not real math. So we're going to use L'Hopital's because the answer is infinity over infinity. And we would get 8x minus 3 over 2e to the 2x plus 1 over x. And I'm going to plug in infinity again. Infinity minus 3, that's nothing. On the bottom, infinity plus 0. 1 over infinity is 0. So it's infinity over infinity again. Top, 8. Bottom, 2e to the 2x's derivative will be 4e to the 2x. 1 over x's derivative will be something. I mean, I'm pretty sure it's negative 1 over x squared, but I don't actually care. Because the top number is just an 8, the bottom will be infinity. Which is 0. So up top, I'm trying to think of the best way to phrase this. Up top, it wouldn't have necessarily been clear that x squared is a bigger degree than e to the 2x. But when you use L'Hopital's to try to compare all of the terms, you get down here and it basically shows that the denominator is a much bigger answer than the top. Now you might have been able to figure it out, because e to the infinity, I mean, like an infinity number of powers is pretty large. This one was just infinity squared, like just a second power. So you might have been able to figure out the bottom was bigger anyway, but this is kind of how you officially find it. Yeah.
Yeah, for e to the 2x, how'd you get the 2 in front? Is it just like you did power rule, but you?
It's outside. Take the 2x.
Derivative of the power.
Derivative of the power, and then that would be, oh, just that, and then multiply because e to the 2x is e to the 2x.
Yeah.
Okay. And then.
Oh yeah, the derivative of e to any power is always itself times the derivative of the power, which that's where the 2 came from, and another 2 down here.
Okay, thank you.
What's the something? What's the derivative of 1 over x? What does this mean? Oh, okay.
What she said. I mean, that's the derivative, but it was nothing up here, so it would be nothing down here.
On the AP test, if we get a question like this, if you just
You won't.
cross this up, oh, you won't get, okay. All right.
On the AP test, what they would give you 1 for zeros.
Okay.
Because there's multiple methods to teaching infinities, and none of them are really actual good notation type things, so they don't.
Okay.
And if they do, well, I'll take that blame, but
I'll throw it to you.
yeah, I'm good at taking blame. I take it a lot.
For anything divided by infinity or infinity divided by anything, what would be 0?
Infinity divided by infinity.
That would be infinity.
Yeah.
And then anything divided by infinity is 0.
When you say anything, a regular number.
Or regular.
Yeah, yep. Okay, now, all the L'Hopital's questions are not going to be just equations. We've got f of 3x plus 2 over x squared minus 4. Andrew, we need to wake you up. Come on. Let's write stuff. No, up here. We need to get you involved. I've had many a days like yours. And the only reason I stay awake is because I'm standing in the front teaching. Okay, what do we do first?
That's a good
Oh dear. Somebody tell them what we do first. Plug in -2 to find out what it is. And if we get an indeterminate, then you do L'Hopital's. Now, there's a good chance it'll happen because this is that section. Okay, so f of, perfect. So 0 over 0. Excellent. Pretty much what we expected. Now you're going to do the derivative of the top and the derivative of the bottom. How do we do the derivative of f of 3x plus 2? And don't forget, you can absolutely call on anybody for help. It's not like, I wanted you up here just to wake you up, not because put you on the spot.
It'd just be the -4 of f prime, right?
Ask them.
Oh, yeah.
He wants to know how to do the derivative of f of 3x plus, oh wait, are you still answering f of -4?
No, I'm just.
Yes, you are. You're a step behind here. Come on. Okay, we got 0 over 0. Now we need to do the derivative.
What is
Oh, I don't know what it's doing.
Okay. The 8 over, and then x squared minus.
Huh?
Or wait, no.
Oh, were you getting the 8 from f prime?
Yeah.
Ah, erase that. I mean, that might be used. I don't know, but erase that.
Oh.
So the -6 plus 2, I think that's what you were using.
Yeah, so I got -4 and then I did.
So the derivative is not going to be the derivative of the numbers you plugged in. It's going to be the derivative of the original equation. So take the derivative of f of 3x plus 2. Does anybody remember how to do the derivative of function notation? Yeah? So the derivative of f of 3x plus 2 is going to be f prime of 3x plus 2 times the derivative of the inside, 3, yep. And then the denominator is normal derivatives of equations. Okay, now we plug in -2 to see if, it might end up being, you, like I said, you might end up using the same info. Yeah, it's going to be the same numbers from the top one because we didn't change the inside. So it's going to be f prime of -4. So 8. Yep, we understand.
Close it out.
Yep,
Okay. And then
yep,
6.
-6.
Yeah.
Excellent.
Okay.
Okay, obviously, the only reason I really wanted this example done is because you have to find your answers differently. The process is the same. You plug in the number to find out what you get. If it's indeterminate, you do the derivative. Doing the derivative of function notation kind of generally means you're going to need to remember chain rule. And if I remember right, the question we're going to have on the test is going to be similar to this, where you're going to have a table of information and a regular equation. So, or it would just be 2 sets of table information, something like that. But you still approach the problem the same, it's just the information you're given is very different. How are we feeling on, I mean, like, feel free to ask away if something up there you just didn't get. Because I can explain any steps, whatever. Okay? We're getting there.
So there's a graph now.
There's a graph. I don't know if we'll get to get every single question in, but we're going to do our best. Okay, using the graph of g of x, find the limit if possible. We're not using proper notation. We're going to be rebels. Okay, so first thing we need to do is find g of 3. How do we do that from the graph again? Look at the height of the graph above g. And then 3 minus 3 is 0.
Excuse me, it's 2. Wait, wouldn't you take this? Oh, no.
Wait, what am I doing wrong?
Well, the slope at 2 is 0.
One of them apply, it's just that's zero.
I don't remember this one being in the notes.
We should skip it.
Well, no, there's nothing wrong with doing it. I was just thrown off because I thought I remembered this one being L'Hopital's and us need to do the derivatives. Okay. I mean, obviously those are the correct answers unless I'm missing something major. If it's not an indeterminate, we're not gonna be able to find the answer. If it was indeterminate, how would we do the derivative from a graph? Yeah, the slope at that spot. So if we were asked,
You're right.
if we were asked at 3, the derivative at 3 would be the slope at that location, which would be 0, but doesn't even work. So since we got an undefined answer, no, I shouldn't write no answer. Undefined, not possible, I don't care how we want to write it. Okay. Here, I was all excited to do the derivative on a graph.
Me too.
The differential equation for the curve y equals h is given by the derivative, given that h is twice differentiable and h of 3 is -1, find that. Ooh. Do we need to interpret that?
Yes.
Okay, do you guys remember what differential equation means?
No.
Derivative. So it's telling us that that is the derivative of h. Okay? Well, the twice differentiable we might need, but I don't know. Plugging in 3, I wouldn't be able to find h because we weren't given h, but it tells us that h of 3 is -1. So I will put in the information that I'm told and or calculate some other ones. So this one's kind of a combination. We don't have a table, but we have one piece that is different. ln of 7 minus 6, ln of 1, 0. I'm assuming that's 0, that's 0. Okay, so now we need to do derivatives. So the derivative would be h prime of x plus 1 over 1 over 7 minus 2x times -2. So natural log was 1 over itself times its derivative. Now I'm going to plug in 3 again. H prime of 3, I'll have to calculate up top by that equation. No, that's kind of annoying because it's got an H, X, and Y. Okay, bottom is 1 over 7 minus 6, 1 over 1 times -2. Okay, h prime of 3. Does anybody know what I should put in place of y?
Y is -1.
There we go. So we know the x value is 3. The y value, we only know the answer is 1 because of that. H of 3 is the same thing as saying y. It's kind of disguised. So we have 9 over 1, which is 9. -2. Now, we only have a couple minutes left, and I'm not gonna go right to the, oh, we have 6 minutes, 7 minutes. Go ahead.
I'm just trying to like catch up. So,
Just kind of how long this would take with real notation.
huh?
I know, with like actual real notation, these are like page-long problems.
Oh, I get it.
Oh, you figured out your question? Okay. This one's kind of weird, so I don't know if you guys need a minute to look at it, to ask what you're confused on, go for it. I'm not trying to rush you. Sometimes I do, just out of habit. Okay. Why do we hate this question? But we can figure out the answer without actually finishing it. So we're gonna use logic to finish. Now, what makes it worse is it's infinity, I know, whatever. Okay, infinity over infinity, clearly. So derivative, what's the derivative of 2 to the x? You guys remember that one? What?
ln of 2
What if we see
x prime, which is 1.
Any numeric base to the power, you treat it like e, but it's not e, but you treat it like e. The derivative of any number to a variable power, you rewrite itself times ln of the base number, that's how you kind of make up for the e, times the derivative of the power. 99x.
98 left.
All right, yep. It's like the 99 bottles of beer on the wall. We can do a lot of steps here. Okay, so this one is going to be infinity over infinity again. And you can kind of see that this is going in a bad direction. What do we know about the bottom, though?
Eventually it'll hit.
At some point, you'll get it down to a normal number
Yeah.
in 98 more steps.
Yeah.
The top would always have what in the derivative? It would always have 2 to the x in the derivative. It's going to be 2 to the x times a super big number by that point. You're just going to keep multiplying by ln of 2 every single step. So, but you have a number over a number, and the infinity would be on the numerator. Your answer would be infinity, which is also code for does not exist, limit, whatever you want to phrase this as, right? Because whenever we're doing the limit at infinity, we're trying to find end behavior. So the end behavior at the far right-hand side of the graph, the height of the graph would be up, would be at infinity. So this is the ones on multiple choice that they would phrase like that. Because infinity is not an actual answer for a limit, so they say it's both. If these were reversed, the answer would be 0.
Where did you get that?
The derivative of a numeric base to a variable power. Oh, I shouldn't write x, I'll write u. The derivative of that is going to be rewriting the exact same info times ln of the base number times the derivative of the power.
So what would you say when it says you have a reason for
We're not gonna get that.
Oh, okay.
Yeah, we're just using logic to figure out the answer.
Okay.
We would never be asked to show 99 individual steps.
Would that be so much fun?
I could be really mean one time or something, I don't know.
Roll up for a second so I can see the little details.
Yep.
That one problem. Show all steps.